Hello guys, welcome to Cisco with Aman Soni, and this lecture number 12. We are going to start the dynamic routing, and today the routing protocol that we will cover is RIP, the routing information protocol. So if you just came here for RIP only and to study what is dynamic routing, so it's good. But if you are just following the lectures, the Ccna classes from the beginning, I recommend that do watch the previous ones. If you are not good enough in those, telnet, SSH, static routing, DHCP, we have covered a lot of stuff already. So let's start the dynamic routing. So guys, let me just bring on today's topic. It is routing and routing protocols. Okay, let me just open this slide again. Yeah, I have prepared few slides. So let's first wrap up the theory that what is routing, what is dynamic routing, different types of routing, and what all the flavors of routing protocols we have. So let me just begin. I'll keep all the extra stuff aside. So first of all, I have already told you that what is routing. We will just take a quick look at that. So routing is nothing but transferring packets or data from one network to another network. It is called routing. So guys, well, few important, like when we are starting routing, we have done static routing also. As you can see here, the three different types of routing: static routing, which we have done; default routing, that we have done also; and dynamic routing, the most powerful one. And you can use the combination of all these three. It is not any limitation. The static routing and default routing we have already done in the same lab. So what are the first routing rules? These are just the criteria, the rule of thumb that how any device forwards the packet. So just take a look. So rule number 1 says if the destination IP, the destination website, whatever that you want to reach is in same subnet in your network, then whatever device from which you are sending the data or packets will directly forward the packet to the destination. The real meaning behind this is the ARP request will be sent to find out the destination MAC address. Meaning what? So let's take example of a small topology. For example, guys, see, I have taken a router. I have a PC in here. Or let's take better a switch. That will really help us understand the topology much better. So the first routing rule simply says that if the destination is in your network, you will forward the data directly to it, and ARP request will go for the destination. Let me just connect these guys. So guys, in here, for example, let me just take a snap so I can draw on this. If I want to reach, let's say, this guy to this guy, then this is one network, right? They're in the one network. So I will send data directly to this guy. Meaning what? When, for example, this guy is .1, .2, .3, .4. You can take whatever network. Let's take 192.168.1.2.3.4. When we ping the 192.168.1.4 guy, then we'll send the ARP. We'll check first of all. This PC will check that my IP is 192.168.1. I want to reach to 192.168.1.4. Is it in my network? Yes, it is in my network. So what I will do, I will send a ARP request to the destination IP of 192.168.1.4 directly, because it is in my network. ARP request will go to ask the MAC. ARP reply will come. I'll get the MAC address. Then I will send the real data. The real data transfer will begin. Okay, so I can't control Z here. I'll take another one. So what if I do not want to reach this guy? I want to reach here, google.com. Okay, it is not in my network. It is way beyond. It is outside my network. So if I am sitting here, if I'm sitting on .1, .2, .3, .4. If I'm sitting on .1, I want to reach to google.com. What will happen? First of all, I have to have the IP of google.com that my DNS server will give it to me. So let's imagine that my IP is 7.8.5.6. It is Google. It is a public IP. Imagine this is my public IP. I will check. I am 192.168.1.1. I want to reach to 7.8.5.6. It is not in my network. It is outside my network. So I have to send. I have to get the MAC address of the next hop, right? So I will send the data in this case, because it is not in my network, to the default gateway. And that is, my friends, is our rule number 2. If the destination is not in the same subnet or the same network, then the device will directly forward the packet to the default gateway. And how it will do that? The ARP request, ARP will go to get the MAC, and the ARP request will be sent not for the destination, not for the google.com IP, but for the default gateway. So, simple rule: if it is in my network, then I will send the ARP request for the destination IP itself. If it is not in my network, if it is outside, then I will send the ARP request for my default gateway. The ARP request will go, the ARP reply will come. Then I will send the data to google.com, whatever request, and it will go to default gateway, and he will forward to Google, because there will be routing and everything in place. This is very, very important, and it is one of the most asked questions, that how do you determine the ARP request is going for what? Will it be for default gateway? Will it be for switch? Will it be for my google.com IP, or for what? So these rules will tell you it is for what. Okay, so these were our routing rules. What? Just for the one more time, let me revise. If the destination in my network, I will send data directly. For that, I need the MAC address of that guy. And how I will get the MAC address of that guy? I'll send the ARP request to the destination IP itself. But if it is not in my network, I will send the ARP request for the default gateway. He will give me his own MAC address, and I will forward the data to default gateway. So let's move on to routing. So what is static routing? Static routing is the one where you have to go to manually, and you have to give the routes for all the indirectly connected networks. This we have already done. I have showed you. This is just one small recap for static routing and default routing. What are the advantages of static routing? It is very easy to implement. We just did only one. What syntax you have to run? IP, route, destination network, subnet mask, then space, next hop. That's it. If you are having trouble remembering all this, understanding static routing, okay, I'll just go to the static routing. Okay, I'll share the link. Just click on that and watch static routing first. Default routing, it is pretty much just like static. The only difference is you will replace the destination network and destination subnet mask with all zeros. It says if you want to go to any network, any subnet mask, just throw the data to this guy. And usually it is done on stub routers. What are stub routers? These are your edge routers. It will be done on your edge of the network, so that you can throw it out. The limitation, one limitation, you have to be very careful when using the default routing. Otherwise you might end up creating a loop in the network. What is a loop? Loop is a never ending thing. So in here, imagine if I have a router like this. I have a red cable. Okay. Because here we have only by default 4 devices we can connect. So I just removed an extra PC. If you want more, you have to go in there, add more modules like we used to do. So imagine what you have done. You have installed a static routing on our default gateway. Like this. Let's imagine it is connected to internet, and you have installed a default route like this from here to here, a default entry, and here to here. So what will happen now? Loop will happen, just like you did by mistake. You imagine I want to go to google.com. What will happen? I will send the data. I will send the ARP request for my default gateway. Reply will come. Then I'll send the data. It will say that I have a default route. It will send data here. Then this guy have a default route backwards, so it will send it again here. Then this guy said, okay, I'll send it back, and it will keep on going. So this is a loop. So that's why if you are installing the default route in one direction, it have to be in that direction only. Okay, do not give a backwards compatible. It's not like backward thing. So be careful when you are installing the default route. So yeah, we can today task also will be use something like this. This topology suits us fine. Let's move on, guys. So we have finally the dynamic routing protocol. So guys, there are dynamic routing protocols and there are also routed protocols. So don't get confused if somebody asks you, like, and this is an interview question, like what is a routing protocol and what is a routed protocol. So the the routing protocol that we'll study, that will carry the routes, are the routing protocols, dynamic routing protocols, RIP, EIGRP, OSPF, BGP. What are routed protocols? The routed protocols, they are the protocols which have capabilities to send data from one device to another device. That will carry real data, like we use IP, IPX, and in Mac we use Apple Talk. So you have to be careful, like if somebody asks you what are routing and routed protocols. The dynamic routing protocols, you don't have to give any static entry, you don't have to do any routing, any route configuration for each and every indirectly connected routes. They will talk to each other, they will send some special packets, and they will automatically learn. Like this guy will send that, okay, router 2, hey buddy, I have all these routes, I have all these networks, and he will share the similar information with R1. How they make this friendship, how they send the data, how the data looks like, different protocols have different formats and protocols and their own RFCs, the guidelines, predefined one. But end of the day, doesn't matter if it is a RIP, EIGRP, OSPF, BGP, they talk. They will talk, they will share information, and somehow, somewhere or another way, they will share the routes. And that's how communication will happen. So what's your job? What's your job in that? When they are automatically doing all the stuff, your job is only to configure them properly and see that they have forming the neighborship that is needed, and that's it. And then they will start on their own. Your job is only that. So as routing protocols, when we start, there are two broad categories of routing protocols. One is IGP, interior gateway protocol, and exterior gateway protocol. So guys, interior gateway protocol is like what? In their interior, you can think of them like this. Meaning what? You have to before that learn a term. The terms means autonomous system. So an autonomous system is what you can simply, in rough term, you can refer it as an organization. Or an organization can also have multiple AS also. If it is very big, if it is very huge organization, it can have different AS. So autonomous system is what? If somebody asks you the definition, you can simply say it is a collection of routers and switches and another network devices managed by a single organization. So this is your AS. So it is just like the logical domain, you can say. AS is like your logical domain where your router, switches and all within a logical boundary. And you can also give it a name or a number usually. We say that this is autonomous system number 100. The another AS that we have is 101. So the routing protocols which are designed to work within one logical boundary, within one autonomous system, are interior gateway routing protocols. The another one is exterior gateway protocols. They are very complex, they're very hard to manage, and even they're like very big. We in Ccna we cover only the basic introduction and very basic lab of EGP, because they're not as straightforward and as simple to configure as the interior gateway protocols. Why? Because their job is to make the whole autonomous system communicate with another autonomous system. So if I have too big, like I have hundreds of routers, switches, firewalls within one AS, and I have another AS which have similar setup, a lot of routers, switches, firewalls. These two big organization autonomous systems, if they want to communicate, they will run some EGP, and within the organization they'll be having their own small IGP protocols running. So how they will reconverge, how they will convert one protocol information to another and all everything, it will see in later on. Okay, you have to do CCNA, you'll see how IGP works, you have to do CCNP, how EGP works, and with your own practice lots of lab, then you can make a very full-fledged network diagram topology consisting everything. Then, so let's move on. That okay, within an organization, within an AS, okay, I won't say organization. From now on I'll just say AS. So within an AS, we can have these three different protocol as well: the distance vector, the link state, and the hybrid, or many people call it enhanced distance vector. So the distance vector, link state, enhanced distance vector. Distance vector, guys, is pretty straightforward. It will just work on the distance. Okay, so I'll show you an example. It selects the router, the best route, on the basis of some distance. Some distance criteria will be there. One very famous that in today's protocol, the RIP, is a distance vector. It will use what is called as hop count. So hop count is very simple, like how many routers I am crossing. So if I have a network scenario like this, I have one router here, one router here, one router here, like this, and I have only one router here. Let's do the connectivity. I'm connected like this. Okay, so guys, if I have this is my destination, and in here I have one network that I want to reach now, and I'm sitting here on the source, and RIP is in place everywhere. RIP is working, it is sharing the routes. So this guy will share the information from the top side that I have this route, I have this network information. He will pass on, and he will get it. So tell me, if the route, if the network address is being learned from top side, how many routers is it crossing? It is crossing 1, 2, 3. So the hop count will be 3. So when the route will come, it will say that if you want to reach this network, it is 3 hops away. Okay, so this won't count because I'm sitting here, right? It is the source. So it will say if you want to reach there, you have to cross it via 3 hops. And if the same information, the same network, the route will coming from here, he will say okay, and here I will pass on via RIP, routing information protocol, and here it will say that I am that you can reach this network via 2 hops. 2 hops means there are only two. It's 2 jumps away. I'll do 1 jump and I'll do another jump, and that's it. So now which route is the best one? The bottom one, right? The bottom one route is the best one. It is the best, and it will be selected and it will be put in the routing table. What is the routing table? It will be just like the directory. It's like your Google Maps final version where you have the best routes installed. Google Maps, we have a lot of routes, streets and all, but if you put a source and destination and you search, you will get the best route. So that is just like your routing table. So distance vector is pretty easy. It will just take distance into account, and that's it. Okay, so RIP works like this. So what is a hop count? Hop count, when a packet crosses a router, that is called 1 hop. Simple as that. If I'm crossing 3 routers, I am 3 hops away. Okay. Link state are not that simple, not that straightforward, because they know that the hop count is not that good of a measure to calculate the distance. So that's why link state have their own little complex mechanism. I will just talk about it in a minute. But before that, why it is called link state. Link state is called link state because it monitors, it works on the state of the link. Meaning what? Whenever any link comes up or goes down, it will send an update. It will say that okay, link came up, some network came up, and here is the information about it. Or if somebody goes down, he will say to its neighbor that hey dude, something went down, this guy went down. But distance vector is not like that. In distance vector, they will just send the information. That's it. Meaning what? We have some time, like there is one timer running. For RIP it is 30 seconds. After 30 seconds, I'll send the update. And if this guy goes down, after 30 seconds, I'll say, okay, this guy is down. And if a new guy comes, a new network 2 comes up, it will not just send immediately. No, link state will do that. It will send after 30 seconds that go, this new guy came. Do you know? It is like that. But link state is advanced. When something happens, link goes up, link goes down, it will send update with a sequence number. This is nothing, don't get worried about. This is just hex number starting with update 1, update 2, update 3, so that it can know that, okay, which update is the latest. What are the example? OSPF and ISIS. These two are link state routing protocols. So enhanced distance vector is a hybrid. It is a distance vector to its core, but it is enhanced version, meaning what? It also act as link state, meaning it will also send information when the link goes up or down. Okay, so this is also work on distance vector routing protocol, but it is little hybrid, sort of thing. And it is also the reason you can say it is also one of the fastest. If you ask whether RIP is the fastest routing protocol, OSPF, ISIS or EIGRP, when we talk about convergence, how fast it is telling converge all the networks in every device, every router in the network. So EIGRP can do that fastest. Okay, so why? I'll talk in a minute that why the hop count is bad of a measure. It is bad because I'm choosing this path, right? But what if in here I have 1 gig link, 1 gig link, and 1 gig link? And in here, like 1 gig means 1 gigabit, 1000 Mbps link. But what if, guys, I have only 10 Mbps link here and have only 10 Mbps link here? That's it. So you tell me, when I'm sending the data, which path is the fastest? Can you tell me? It is obvious, right? The top one is the fastest. But if I'm using RIP in my routing table, I'll be having the bottom path only. Even I know the data will be very slow, but I will send all the data via this path, because the RIP is very old protocol. It is not as advanced as link state. Link state will take into account the bandwidth also. So does the EIGRP, the enhanced distance vector. That will also take care of the look at the bandwidth, and both of them will say that we will look at this top path and it looks better to us. But RIP is old school. It will just look at the bottom one and that's it. So this was our RIP. So I just made a small topology for you, or not topology, a diagram. So this is explains, like, just to give you a rough idea that what is static routing is not here. It is just another, like, we have static routing. In static routing we have only nothing, like no sub branch, not in default routing. But in dynamic routing we have IGP that run within an AS, EGP that run outside an AS that connects AS. Only BGP we have only one big protocol, okay, the border gateway protocol. But within an AS we have the option, either we can use distance vector and link state. So in here I have not put an advanced distance vector. I have just put EIGRP in here only, because EIGRP was it was evolved from IGRP. It was an old protocol and it was a distance vector. But EIGRP, you should just keep in mind, it is advanced. It is not your traditional distance vector routing protocol. So now let's move on to our routing RIP lab, and let's see how this RIP guy works. You can see here we have RIP version 1 and version 2, but RIP version 1 is obsolete. Nobody uses it. It's not even in our CCNA. So we'll just do RIP version 2. But what I'll do, I'll show you a tabular difference. While doing the lab, I'll show you what is the difference between RIP version 1 and version 2 and why they made RIP version 1 obsolete. So guys, let's move on to lab. Yes, we'll use this topology. It will suit us fine. What we can do, we can create one more network here. Oops, PC actually. This will be our R1. R2, and let's take here the network, this time little different because I want to show you something. 10110 network, let's take. This will be these will be the IPs. Let's give for now .1, because if you might have remembered, I told you that we'll do something called as a DHCP relay agent. So that will do after RIP, because first RIP have to be in place to give us full connectivity from everywhere to everywhere. Then we'll create one guy our DHCP server and use a relay agent to reach it, which is outside our network. So guys, in here you can imagine it like this. This is one network, okay? This is one network, and this is our edge router, and this is outside our network. This is outside some, you can say, some other department or something, and we want to make these two different networks communicate. Here let's take
can you repeat it?
Yeah, these are, just imagine, see in your head, imagine them as two different networks. Like this is another network, this is our home network, and we want to reach outside. Okay, so here we have some option. If you want, we have already done this lab using static routing, but today we will do using the RIP. Meaning what? R1 has how many routes? R1 has 10110 route, the 10110 network, and this 12110 network. R2 has 192.168.2.0 network and this network. So R1, when we start RIP, what will happen, how RIP works, all the routing, the whole routing table, it will give it to its neighbor. He will share the routing table information with its neighbor. So he will say this route will be in the routing table of R1. When he will share it, R2 will say, okay, I don't know this network, it is a new information, and I will install it in my routing table. Then R2 will say, share its own routing table information to R1. R1 will open it and will find it 12110. He'll say, okay, I already have it, so skip. And I have 192.168.2.0. This is a new network, so I will install this in the routing table. So that's why we have no need to configure it manually like we used to do in static routing, but we have to start RIP protocol properly. But first of all, as always in every lab, first thing first, IP addresses have to be there on all the ports. So here we'll use 12.1.1.1, it will be 12.1.1.2 here, and here 192.168.2.1, here also it will be .1, and we want to see the interface, otherwise we will not be able to configure it. So always show port labels. Here we have to configure on F00, and here we have taken this time something different, the serial cable. Okay, so don't get like confused that for dynamic routing or if we have to use serial cable just like that for no reason. If you want, we can put also the same old fast Ethernet one. Okay, but just to show you something different, I have used this one. So just click on R1. Okay, let's put it here. And let's configure the IP address that we already know. No, nothing new. Enable config t host name. Let's make this guy R1 so that we won't be confused. And just this is interface F00 on the left. We have 10.1.1.1 and no shutdown. It will be up and running. The other side, just see it is actually serial interface. It is interface. Let me first go out. It is interface serial 20. So if you want, you can do interface serial 20, or you can also just write interface S20. Okay, the difference, it is used for WAN connectivity for long distance, and the speed is very slow. It is around 1.6 Mbps something, the speed for this, but fast Ethernet is 100 Mbps. So interface S20, but everything, the how you configure it and all will be same. So 12.1.1.255.255.255.0, no shut. That's it. As you can see, it is not up. Why? Because the other side is not configured properly. see the background, config T, host name R2, interface serial 20, IP address 12.112.255.255.255.0, no shut. Then I can see I haven't exited. I can just move from one interface to another interface also. 192.168.2.1. No shut. That's it. But what have left? The PCs. So right now we don't have any DHCP. So let's just configure 10.1.1.1. Oh, sorry. See, that's why I tried configuring 10.1.1.1, but actually we have 10.1.1 here. So let's make this guy 10.1.1. Let's say let's take 10, 20, and 30. This should do the job. 10, 11, 10, 255, 255, 255, 0, and do not forget to give the default gateway. Okay, because if you don't give the default gateway, it doesn't matter. Even if routing is there, the PC won't even forward the traffic to its default gateway. It doesn't matter how much routing you have done. 10, 11, 20, 255, 255, 255, 0, 10, 1 is my default gateway. So up till now we have only doing the basic stuff that we already know. And don't get confused on why I have taken this IP address, y/24, y 192.168, just like random. If you want, I could have taken here 70.0.0/8. I could have taken this one also. Okay, so don't get like a lot of people, they get confused why this network, y/24, y 10. You can take whatever you like. 192.168 2. Let's take 2.10 here also, and my default gateway is this guy. Let's do 10 here. So now we do not have any routing in place, so that if we are sitting on R1, it can only ping, which is in our network, 10.1.1.10, 20. My PCs, because they are in his own network, they are in the same network, I can reach them. I'll just send the ARP request to get their MAC, reply will come, then I will generate the ICMP echo request, IP echo reply will come, and I can ping 12.1.1.2, which is also in front of me. But what I cannot ping, I do not know anything about this guy. I'm like blank. I'm blank. Why? Because even if you try to ping 192.168.2.1, it is also on the router which is in front of him. This is actually 2.5. Okay, this was 2.2. It was here. Show IP interface brief. On R2 we have two IPs. So I can reach this from R1, but I cannot reach this. Why? Even it is directly connected to me. But see, that's not how router and switch and PCs and all, they don't work like this. Okay, they don't say it is directly connected or not. They will just look at their path, how they're programmed. If they are a PC, they will check if it is in my network, I will send forward. If it is not in my network, I will forward to default gateway. How routers work, router will look at the routing table. They will say, I have no idea what is 192.168.2 or 1, like I'm blank. So it will just drop the packet. That's it. So same thing here. If we go to R2, I'll try to ping 192.168.2.10 was it? Yeah. It is just below me, directly connected, and also in the same network. I can ping this guy also. Same network, directly connected one. But anything 10, I have no idea, because R2 is also blind to this network. So now we are going to do RIP. They will start talking, and when they start talking, they will advertise. They will advertise what? They will advertise their whole routing table to each other. So how to enable RIP? So we have to create some theoretical notes. So guys, we have to configure RIP. So how to enable RIP? So the steps are, you have to go to RIP config and turn it on the interfaces which are directly connected to it. Okay, or just on the interface, just on the my local interfaces. I can also write it like that. Once enabled on an interface, it will send out RIP packets out. In our case, it will send out the we just have only like two interface, will enable, and it will send out the routing table, routing updates. So let me show you something. I will turn it on this serial 20 first only, and I will show you that whether our R2 is receiving. I'll just turn it on here on serial 20 and here on serial 20. That's it. Ideally, what is the ideal scenario? You have to turn it on serial 20 and you have to turn it on the another side also, because on all the directly connected interface, the routing protocol have to be turned on. Okay, when I say routing protocol, I mean RIP, EIGRP, OSPF, because these are the three main protocols that we will study deep in Ccna. RIP, EIGRP, OSPF have to be turn it on the interface. How will you do that? Go to the RIP config mode and turn it on one by one. How it looks like, let me show you. I will go to the, first of all, yes, you have to be config mode, then you can do any sort of config. Then how you will go to the router RIP, the RIP configuration or RIP mode, you can say it whatever you like. You have to do router, and this is the only command, router and the routing protocol name. Okay, so I'll just do a question mark, and then if you want to configure RIP, you have to do RIP, go into the RIP config, OSPF, EIGRP, BGP, whichever you'll do, you will enter into that config. So if I do RIP, I will enter, see, I am in the RIP configuration mode now. If I do question mark, I can do a lot of commands. A lot of commands are there. Okay, we are not going to do all of them. A few of them I'll tell you. Okay, so like one of the most important command in routing protocols is the network command. And the good part that the network command is in all of them, in RIP, EIGRP, OSPF, even BGP, in all of them you'll be using the network command. What network command does? Read it. It will enable the routing protocol on the interface, on the IP network. Okay, how? I will say network and question mark. You have to give the network ID, and whichever interface have that network on the router will start that routing protocol. So we are in the RIP, right? We are in the RIP protocol, and I want to turn on this interface. So I can't say that okay, router RIP and then interface serial 20. No, I have to say what is the network running there. So I know that the network running on that interface is 12.1.1.0. So I will say network 12.1.1.0. That's it. As soon as I say this, I have turned on RIP on this interface. So let me do one, and I told you that we have to turn on version 2, right? Version 1 is obsolete. I'll tell you what is the difference. So we have to just say that I want to run version 2. That's it. Now let's go to this guy. Same thing, and before that, I haven't received. Why I haven't received? Even if this guy will send, I will not be open to it. Why? Because it is just like Japanese to me. It is a different language, it's a different protocol. I have to turn on that language, that protocol, so that I can understand it. So same thing, router rip network. Okay, I'll repeat, it is very important. The network ID you will give, and whichever interface will be having that network running will turn on the protocol. I have done that. Exit it. Exit. Show IP route. I told you it might take 30 seconds. Oh, one thing we I think forgot. We have to do version 2. Router rip version 2. But I want to show you something, that even if you will do that, you will not see much here. Why? Because you have turned on this interface, this 12 interface. So I will send out 12 network only, right? I will say that I know 12. But what is the benefit of that? This guy have already knew 12, right? You have turned on rip, it is sending out. It is also sending out. He is saying, dude, I have 12. He's also saying I have 12. But 12, both of them already knew. Okay, I told you, yes, it will be send out the routing table, but for that you have to enable it on all the directly connected interfaces. Have you turned it on this interface, which is 10.1.1, which is running the network 10.1.1.0? No, you have not. That's why you are not seeing anything. Nothing is there. So that's why we'll go to the R1 and we'll configure it properly. We'll say router rip. We have turned it on here. Why? So that it can send out the update. But it will only send out the 12 update. That router 2 already knew. But as soon as I turn on here, he will send out the 12 network information and the 10.1 network information also. So I will say, okay, network 10.1.1.0. This is my network. I'll go to another site. And immediately, previously only 2 entries, wire directly connected. But right now I have seen a brand new network coming, which is the 10 network. Why my neighbor? Just learned it 7 seconds ago. Okay. And ideally, I should also configure it here. Router rip. Now you don't need to do version 2 and network 12.1.1.0 because you have done it already. I just have to enable it on my other network also. That's it. If I don't do this, my rip will, I showed you what will happen. It will not advertise that network to the neighbor. So I'll go to another side, R1. Previously, only 2 guys I know, but now rip is enabled. They're sharing their routing table. And if you do show IP route, you will see 192.168.2.0 new route came. And just like that, we have configured IP address array. Everything is configured. Previously, R1 was not able to reach this guy, but now if I do ping 192.168.2.10, it will immediately start pinging because I have the route wire rip, and it says I'm learning this route. If you I'll show you just in a minute. We'll read this whole line word by word. Each word I'll tell you. In short, now it says if you want to reach to this destination network, this subnet mask, send the data to 12.1.1.2. I will send it to 12.1.1.2. And if you have remembered correctly, then when we have studied static routing, how you will give the route, you will say that if you want to reach 192.168.2.0 network /24, if you want to reach to this network, throw the data to 12.1.1.2. This was our syntax for static route, right? And if you look at RIP, it is saying the same thing, that if you want to reach to 192.168.2.0 /24, throw it to 12.1.1.2. So now it is coming automatically. Why? Because they are telling each other. And same if you are sitting on R2, we can ping the other guy. We can ping all of them, 10.1.1.10, 10.1.1.20, 10.1.1.30, and we can ping all these PCs to this guy, like all the PCs can ping with each other. Alright, let's try pinging the guy over the other side. And it is pinging. I'm receiving the reply. And same thing, this guy can also ping. 10 1 1 10 10 1 1 20. With Control C, if you want, you can stop ping in midway. 30. It is also pinging. So full RIP has configured fully, and just for your reference, I'll put it here. That for R1, this is all we have done. Config T, router RIP, tell the version, then the network 12.110, network 192.168, 1. Oh, sorry, it was 10.110. And for R2, we have done similar. And also, the guys, once you are in the router RIP mode, you can give version 2 afterwards or network afterwards. It is the same thing. It doesn't matter. Okay guys, so you do it like this: config T, router RIP, version 2, and this was for R2. You have to give the network that is running on that side 192.168.2.0, and they started pinging. Apart from these, what we have done, just assign the IP address properly everywhere and the PCs properly. Okay, so I want to show you some few tips and tricks of RIP also. Okay guys, so the very first thing that I want to show you is the comparison between RIP version 1 and version 2. Yes, I have told you that RIP version 1 is obsolete and RIP version 2 is the RIP version 2 we are using now. So, but what's the difference between these two? So these are the difference. So RIP version 1 is these particular features, and RIP version 2 I'll explain one by one. So RIP version 1 is, guys, is class full. One of the biggest difference that is between version 1 and version 2. I have told you about class full and classless. If you have remembered, if you are following all the lectures religiously, class full means that the network is following the class boundary. In simple English, if it is using its default subnet mask, that's it. If it is class A, it should be using class A subnet mask, then it is class full. But if the network is not using its own like what the subnet mask it was supposed to use, if it is not using that, it is classless. Meaning what? In here, as you can see, if I ask you if it is class full or classless, it is classless because it was supposed to use /8 255.0.0.0, but it is classless. So RIP version 1 do not support these. RIP version 1 do not support these. What do you mean won't support? Like it won't send it out, or how? If you use RIP version 1 here, what will happen on R2? The route will come via RIP, but it will look like this. It will say that I'm learning this route via 12.1.1.1. If you are using RIP version 1, because it doesn't support classless, it will make it look like class full, isn't it? But it doesn't mean that you won't have connectivity. Yes, it will just look at the first octet 10 and forward it, that's it. But it will not be showing you the correct network, which can cause problems. If you have different networks, if you have 10.110, 10.220, 10.340, 10.5.0, different 10 networks, then it will cause huge issue. Your ping will not happen. Some weird things will start happening. You will lose some few connectivity will be there, few connectivity will not be there. So that's why RIP version 1 is obsolete, because everywhere nowadays we have classless. RIP version 2, if you go while configuring the RIP, you do RIP version 1, then you can use the classless networks. It supports classless networks like we are using. Both are distance vector. For the metric is hop count for both of them. Hop count maximum limit is 15. If it is more than 15 hops away, I will not show it. Why? Because RIP is old protocol. It does not support very huge big topologies with a lot of routers. Updates, meaning the updates that I'm sending. The routing update that is sending every 30 seconds. If RIP version 1 you are running, it will be sending out on broadcast address of 255.255.255.255, which is a universal broadcast address. But if you are using RIP version 2, it will not just broadcast it to everyone. It is not. It shouldn't be like this. So RIP version 2 is advanced and it will send multicast. What it means, when I'm sending the update, the destination IP will be 224.0.0.9 for RIP version 2. And when the router, if it is running RIP, it will receive it. And if it look okay, you came for 224.0.0.9, and it will immediately know, yes, it means you came for RIP version 2. If it is running EIGRP here, let's say you have enabled EIGRP, it will receive this and it will discard. Because for EIGRP, we have some special address, some special multicast. For OSPF, we have some another multicast address. That's why both RIP version 2, EIGRP, OSPF have their own reserved multicast destination address. But RIP version 1 is old and it just simply broadcasts like a dumb guy. Okay. So these are some advanced stuff that send version 1, send version 1, send version 2, send version 2. Meaning what? It will send only version 1 and receive version 1 only. Version 2 will send only version 2 update and receive only version 2 update. Meaning what? That if we are running version 1 here, if we are running version 2 here, then they will not accept each other's updates and it will not work. You will not see the RIP routes. Classful, classless, already told you. RIP version 1 supports no authentication. Meaning what? That if you want that, see, if I connect another router R3 and if I turn on RIP on both sides, immediately it will share all my routes to the third person, the third router. There is no protection. But if you want in RIP also, in the RIP config that we have done, there are few particular command line. Here you can put some passwords. Okay, some password will be there. And when the other side will put that password, then only you will form the RIP relation and share the routing updates. So you can do that only in version 2. One thing I missed on purpose, AD value. What is AD value 120? You can see. So AD value is a concept in itself. Let me just write it down. Administrative distance of RIP is 120. Then what is the administrative distance itself? What does it mean? So it is, guys, nothing much, but it is a parameter to, you can say, it is a parameter to compare the reliability of routing protocols. Okay, it is, you can say, it is just like to measure and compare reliability of routing protocol. Meaning what? If you are running, for example, and also the lower is better. For static routing, you will be having something else. One, I'll show you also maybe in the routing lab when we put the static or default route. For RIP we have 120. For EIGRP we have 90. For OSPF we have 110. EIGRP there is one special also. For that, the special is 170. Meaning what? If, see, just in case I'll show you a scenario. If my router is receiving the route from RIP also, from somewhere, from one side from RIP, another side from EIGRP, I cannot compare their metric, right? Because I told you RIP uses hop count, EIGRP, OSPF, they work on bandwidth. So I cannot compare. It's just like compare, like you can say, it's like comparing kilogram, kg with centimeter. How can you say 5 centimeter versus 2 kg? Can you compare these two? No, these are different parameters. So that's why all the routing protocols have a AD value, and the routing protocol with the lower AD value is always more preferred. It is considered more reliable. That's why the static routing have the lowest AD value, most reliable. Why? Because you are putting it manually. So RIP is 120, and this is what you can see in the route also. If you do show IP route, you will see that I'm learning 192.168.2.0/24 via this guy. What is this 120? This 120 is nothing but my AD value. And what is this one? This one is nothing. It is just the hop count. So it says via RIP, I received this route with the subnet mask. The AD value is 120. It is one hop away, and I'm receiving it via 12112. I just learned it this many seconds ago on my serial 20 interface. That's how you read the whole thing, word by word. One last thing for today's topic is, I told you that version 1 is class full and version 2 is classless. But there is a question, does RIP version 2 is classless by default? I told you, yes it is. But the reality is no. Maybe we should say works with classless networks by default. No, it supports them, but by default it will convert them into class full. Example like this: if I'm receiving, if the real network is, like in our case it is 10110/24, another router will show 1000/8. Even if you are having RIP version 2 running, because I'll tell you the reason, but first let me just prove it to you. We have RIP version 2 running both sides. In here we have 10110, but if you go on R2 and if you do show IP route, you will see that I'm seeing 1000/8, hence proof. But it is wrong, right? I told you RIP version 2 supports classless. It should show us classless, like it is, like the way it is. But it will not show you. Why? Because even if you're running version 2, because by default auto summarization is turned on. Auto summarization will do what? Auto summarization will summarize the network into its class, will summarize the classless network into its class full form, like you can see on the top. So what you have to do, you have to turn off the auto summarization. So how you will do that? The command is pretty simple. It is no auto summary. Here you have to do no auto summary, and obviously on the R1 also you have to do it. So let's go on R1. Let me show you something. Router RIP, and I am doing no auto summary. Version 2 I have already done. Let's go to R2. You will see one weird thing happening. You can see the new route is coming, 10110/24, like it should be. But why the hell I am still having this route? Because it is the old one, and it will not just go like that. Okay, there are some timers that are in place. Look here carefully. 19. This is the new update, the new one. And after every 30 seconds, it will reset its timer. See 0. Meaning what? I will go. Let me show it. I'll go till 30, and as soon as I'll receive the new update, I will make this counter 0. But the top one is the old update, and it will keep on going for some time. So see 18, 21, look at this one carefully, 22, 25, and it is about to go to 0 around C. As soon as I'll reach around 30 seconds, I'll receive it, my new update, and I will make it 0. But this is, I haven't received till 1 minute 22 seconds. Why? Because there are something known as some timers. Let me show you the timer thing. Here are the timer, guys. See, update timer is every 30 seconds. What I want you to look at the invalid and the flush. Invalid says interval, interval in seconds, like 180 is the limit, and it should be at least 3 times the value which it is by default. And after 180 seconds, what happened? The route will become invalid when there is an absence of update. So after 180 seconds, I will say around 3 minutes, I will say this route entry, this old entry is invalid. It is invalid. It is saying possibly down. That's how it in reality it shows. After 3 minutes, I will say it is possibly down. Something might be wrong. Okay. See, RIP is so slow. After 3 minutes, it will say something went wrong. Something is missing. Okay, but ideally it should have been immediately removed the old update, right? Because we have changed the setting, we have done no auto summary on other side. And it will take 60 more seconds. So total 180 seconds plus 60 seconds, which is 240 seconds. I will wait for 240 seconds for it to flush it out. Meaning what? After 240 seconds, after 4 minutes, I will remove this entry. Ideally, it should have been done seconds, like immediately when we have done some change, immediately it should be like that. And which is what happens in EIGRP and OSPF, because they are advanced and they are link state. Immediately, if something happens, immediately they will show you the change within seconds. RIP, on the other hand, takes 240 seconds to remove the old entry. And what is this hold down? Hold down is also a holding timer, meaning what? See, if I'm receiving en route from my current neighbor, and if it is not coming, if it stopped coming, then I will not receive the new route from somewhere else. Even if some new neighbor comes and it is showing me, it is giving me the same route which my old neighbor was giving, I will wait for 180 seconds just to suppress, as a respect for my old relationship with my old router. I will wait 180 seconds just to check if it is coming up or not. If it is not coming, screw him and I'll accept the new update. Okay, so this hold down I cannot show you here. Update I have showed you, it will become 0 after every 30 seconds. Invalid I have shown you, it says it will go possibly down. Okay, and after 4 minutes, I think 4 minutes are done. Not now, like it will take some little more time, and it will remove it after 4 minutes from here. So also we should do no auto summary on this side, but in here, see, even if you don't do, it won't matter. Why? Because in here on the right side we already have a class full network. It is a class full network, and that's why it will show you just like that. If you want to see the RIP details, like what all main important stuff is running, the command is show IP protocols. It will show you what protocol you are running. I'm running RIP. I'm sending every 30 seconds the update. Next due in 27 seconds, I just send it. And I will declare a route possibly down or invalid after 180 seconds. Hold down is 180 seconds, told you already. I will flush down after 240 seconds if nothing comes. And some advanced stuff. And yes, I'm running right now RIP version 2 for both sending and receiving. Automatic, yeah, this is what I want to show you. Automatic network summarization, or auto summary in short, is in effect because we have not disabled it. We have only disabled it on R1. Remember, we have only disabled it on R1. On R2, it is still running, but it won't have any effect because we do not have any classless network here. But still, it is advisable. It is recommended that if you're running RIP version 2, you should do it. here also. So if we do router rip, no auto summary, exit out, show IP protocol, it will show you that automatic summary is not in effect. These are the two networks that I'm advertising, and my AD value is 40. Okay, so these are the main and most important things that I want you to remember for the RIP. And guys, as you can see, if we went in here, we did no auto summary and version 2, immediately it becomes classless. Why? Because it is RIP version 2, it supports. But if you do not give RIP version 2, if only RIP version 1 is giving, if you have configured version 1, or if you do not configure this command, even if you do this line of code and you remove version 2 from here, then doesn't matter if you have given no auto summary or not, on the other side you will always see 10.0.0/8 if you are having version 1. So if you want to see classless networks as it is, as how they are in the real life, so just you have to go in there, you have to turn on version 2 and you have to give no auto summary, both of them. One command will not do. Okay guys, so practice this. I'll share this theory file also with you, and let me also just save this image. What image? This is our task right here. I'll save it for you and practice this. And you how you'll practice, if you want, it's up to you. You can also practice version 1. It's you just have to configure RIP version 1 without anything. Okay, let me just save it, and I'll also save the theory file as well. Oh, I think we have got deleted it. Okay, and the project also I'll save later on. So this was all about RIP version 1, version 2. Okay, so AD value, try to remember all the AD values that I've shown you. The RIP version 1, RIP version 2, for RIP we have 120, EIGRP we have 90 and 170 special, and for OSPF 1, because all these are interview stuff, like what is the AD value, what is hop count, how RIP EIGRP is different from OSPF, and how RIP version 1 and version 2 are different from each other also. Okay guys, so this was all for today's lecture. We have studied RIP, a lot of stuff, AD value, summarization, classful, classless. Okay, so if you need like rewatch this video, if you and do this task that we have done today. Okay, and if any doubt anywhere, you are stuck at somewhere, routes not coming or they're not coming as they should be, just let me know and I'll be happy to help you guys. Okay guys, so see you in the next class, and we'll probably do EIGRP, and I have not forgotten about the DSCP, but I don't want to overwhelm you with a lot of information, so don't worry, I'll show you the relay agent, I promise. Okay, it's pretty easy. So in next one I'll show you. Okay, so try to do all these stuff and see you guys in the next class.